Good afternoon, everyone. Today, I will explain about this inspection technology. Okay, in the last class also, just the recap of the last class. In the last class, we have you have seen, okay, the so in the last class you have seen the storage system performance and strategies. That is a bulk storage, pallet rack system, drawer storage, automated storage system. What are the objectives of the automated storage system? And then the types of automated storage system, automated storage and retrieval system. What are the types of ASRS applications, and then carousel storage system, horizontal carousel system, carousel and the applications of carousel systems, and what are the engineering analysis of automated storage system. So today I'm just explaining about the inspection technology. Okay, so in this inspection technology, so how, okay, what are the different sections? So today I will take, okay, these two sections, that is fundamentals of inspection and automated inspection system. Okay, so these are the different sections we have. In the last class also I have explained about the fundamentals of inspection, okay, automated inspection, contact and non-contact inspection methods, okay, and CMM, coordinate measuring machine, surface measurements, machine vision system, other optical inspection method, and non-contact and non-optical inspection techniques. Okay, this section includes this. What are the different fundamentals of inspection? So fundamentals of inspection, in this again we have four types. One is type of inspection, and the second one is the inspection procedure. What is the procedure for the inspection? Third one is inspection accuracy. Okay, what is the accuracy of the inspection? And then fourth one is inspection versus testing. Okay, how you are going to test, how you are going to inspect. What is the difference between the inspection and testing? So next is, what is the types of inspection? Okay, in the types of inspection we have inspection of variables and inspection of attributes. So in which one or more quality characteristics of interest are measured using an appropriate measuring instrument or sensor. Now here in this particular case, the characteristics of interest, okay, is anything. As in the last class also I have explained about the diameter of the shaft. So similarly, the square component, that is a prismatic component, that is the length, width and height of that particular, that is the quality characteristics. Okay, so in which one or more quality characteristics of interest, say one or more means what? One is the diameter. If it is if you take the one square component and one the diameter on the other on that particular component, if you check, so that is the thing. Okay, I'll just explain that. In the types of inspection, so quality characteristics is, one is prismatic, another is the circular component or a cylindrical component. So these are one or more quality characteristics. So quality is, yes, One is a surface roughness. Surface roughness is also one of the quality. Now you are going to inspect that particular surface roughness using the telesurf or other measuring instruments. Okay, that is the interest actually. Okay, what is the dimension given, or else in some cases they'll give the GD&T, geometric dimensioning and tolerancing. Okay, that they will give in the drawing, and we have to inspect that particular dimensions. So that is also one of the characteristics for inspection. So variables, different characteristics are given. Say like a surface roughness is one characteristic. Second one is for the machining. Okay, the cutting, the one quality characteristics is the surface roughness. Second one is the dimensions of that particular part, and the other characteristics is the visual inspection. Okay, the casting defects. So those are the things will come under this quality characteristics. Okay, that is of interest are measured using the appropriate measuring instrument or sensors. Okay, so that is the variables. So next is inspection of attributes now. Now what are the attributes? So in which the part or a product is inspected. So the part, okay, you take one part, say like the piston and cylinder is a one part, that is the example, and how they are going to inspect. The product is inspected to determine whether it conforms to the accepted quality or standard. How it will be confirmed? So they will take the gauge and then they will use that particular piston and then they will put in gauge and then they will check they'll confirm that particular part is accepted or it is rejected. If it is accepted, then they will take that particular part for the assembly. Okay, and the determination is determined sometimes based on the judgment of the inspector. So whether determination, whether that particular part is accepted or not, okay, whether that particular tolerance is within the limit or not, it is the judgment of the inspector. Okay, and in the other cases the inspector uses gauges. Okay, otherwise he will use the gauge and he will check, okay, whether for the confirm or non-confirmation and aid of the inspection. It also involves counting the number of defects in the product. So how many defects are there in the product? Okay, that count will give the one more type. So that is the inspection with the help of attributes. So next is the inspection for variables and inspection for attributes. So now here in the last class also I just briefly have gone through these particular slides, but today, okay, so I'll take one by one here examples of inspection for variables, okay, and example of inspection for attributes. So measuring of the diameter of the cylindrical, this I have explained. Okay, you take any diameter, stepped diameter or taper diameter, okay, or the other this thing, okay, with some concave or convex type of this thing, okay, diameter, okay, or spheroidal type of diameter. So if something is given, some dimension needs to be measured, okay, so measuring of the diameter of the cylinder, this is inspection by variables. So different types of variables we can inspect that particular part, okay, whether it is a step diameter or the taper turning operation diameter, major and minor diameters or other diameters. So this will come into this particular examples for variables. Now examples for inspection of attribute is gauging, okay, of a cylinder part with go gauge to determine if it is within the tolerance, okay, no go gauge. So whether it is acceptable, whether it is conforming or non-conforming, with the help of gauges we are using. In the types of gauges we have seen, okay, so one is a snap gauge, one is a ring gauge, okay, so different types of gauges are available in the market. So they will check the OD, outside diameter of that particular part, with the help of snap gauges, and the inside diameter of the part they are using the RE gauges, that is the ring gauge for that particular purpose. And in the ring gauge they will use the bore dial gauge to check the diameter within the tolerance or not. Okay, so these type of no-go gauges they are using for inspection. This will come under the inspection of attributes, gauging of a cylindrical part. Okay, if it is a cylindrical, okay, if it is a hollow part, then they are using, for ID they are using the ring gauge. Okay, so next is the measure the temperature of a toaster oven to see if it is within the range specified by the design engineering. So The toaster oven, okay, how they are manufactured? Okay, they are manufactured with the help of some range. Okay, beyond that range it will not go. So there is a temperature sensor is given. Okay, within that particular temperature it will heat. So see if it is within the range specified by the design engineering. So while designing that particular oven, okay, design engineering will specify the upper limit and lower limit of the temperature for the toaster oven. So measure the temperature of the toaster oven, see whether if that particular thing is within that limit or not. Okay, so how much you are going to keep the temperature, so it will measure. So that is also variable, so we can change, okay, the temperature of that particular thing. Now here examples of inspection for attributes: determining the fraction defect rate of a sample production part. Fraction defect rate, okay, sample production part. If I want to produce n number of parts, and we'll determining the what is the fraction defect rate. Okay, defect rate, how much is the fraction defect rate, that actually we are checking with the help of the different type of gauges. So that is fraction defect rate. Okay, how many counts we are using. So that comes under in the inspection of attributes. Okay, next is measure the electrical resistance of electronic component. Measuring the electrical resistance of an electronic component. Electrical resistance. So how actually what is the resistance of the electrical component, electronic component? So measuring of that, how that is with the help of variables. Okay, inspection for variables. So different this thing we are taking. Okay, variables we are taking, and then we'll check the electrical resistance of an electrical component. Okay, any electronic components we are taking. Then here in the inspection of attributes, counting the number of defects in an automobile as it leaves the final assembly part. So we are checking how 100% inspection we are doing, counting in that 100% or frequency inspection we are counting the number of defects in an automobile, okay, as it leads to the final assembly. Before final assembly in the plant, so we are checking, okay, in the ASRS, after ASRS, before keeping in the ASRS, automated storage and retrieval system, or in the corridor system, we are checking all the parts for 100% inspection, and then it leaves for the final assembly in the plant. Okay, measuring the specific gravity of fluid in the chemical product, this will come in the inspection of variables. Okay, so chemical product, okay, there is a specific gravity of that particular some fluid. Okay, measuring of that particular thing will come into the variables. Counting the number of imperfections in the production run of carpeting. So if you want to manufacture the carpet, okay, carpeting, so what are the how many counts of the imperfections? Okay, so that actually comes under the attributes. Okay, so next. So inspection procedure, okay, this is the second part. Okay, so as I have explained, in the fundamentals of inspection we have the types of inspection procedure. Now this is the inspection procedure. Now how you are going to, what is the procedure for the inspection? So first one is the presentation. Now how you are going to present that? The item is presented for the examination. Which type of item? Okay, whether it is for example, if it is a as cast part. Okay, so if it is a casted part, okay, either it is a FG 250 grade or FG 200 grade or GGG 40 grade, GGG 45 grade or GGG 50 grade, any grade, but how you are going to present that? What is the procedure for that? So first one is the inspection. How you are going to inspect that? Whether it is a visual inspection, whether the casting defect is there on the above surface of the casting or not. So those particular thing comes under this presentation. Okay, the item is presented for the examination. That particular casted part is presented for the inspection, for the visual inspection. Okay. Then other techniques are there. Okay, if destructive testings are there, non-destructive testings are there. Okay, so that is also one of the inspection method. But the presentation is the first procedure is the presentation. How you are going to present that particular part. Okay, for the inspection, and how you are going to check all the parts, whether we are checking with the help of visual inspection, whether we are checking with the help of entity testing, or whether we are checking with the help of destructive testing. Okay, so this is the first part, that is the visual inspection, that is the presentation. And the second one is examination. In the examination, the item is examined for non-conforming features, non-conforming. Okay, examination. So in the examination, first the item is examined for none. Whether the component is rejected, first we are checking that. Okay, acceptable product, yes, we are checking all, but whether it is examined for non-conforming. So non-conforming we are checking. Okay, well, if it is non-conforming, we are just rejecting that particular part. So that is how we are examination. What, see, why we are going for the examination? Because we are sorting those particular parts, that is acceptable parts and non-acceptable parts, or rejected parts, okay, or non-conforming parts. So conforming parts, yes, the non-conforming features in the sense any features, okay, whether it is a, if you are taking the diameter, the shaft as cast, okay, the roughness of the surface roughness of the casting, okay, if it is in the green sand molding, if you are taking in the green sand mold, or the shell molding process, or your CO2 molding process, the surface roughness is different. Okay, so that is also, surface roughness is a one feature, whether it is examined for non-conforming. So the casting, if you go for the visual inspection, okay, the casting in the drawing they will specify, okay, the roughness value of that particular casting, okay, after molding or after pouring the metal in the mold. Okay, so that is a one feature, okay, that is your roughness, surface roughness is the feature. So we are checking the surface roughness of the feature with the help of this examination. That is the procedure. Okay, how we are checking? Yes, we are checking with the help of the either with the visual inspection, or else we are going for the using the telesurf, we are checking the feature, that particular surface roughness feature. That is how we are examining that particular part. Okay, or else if it is a machined part, then we are checking the surface roughness values. Okay, the surface roughness for roughing operation is different, finishing operation is different, and the as cast is different. So it is specified in the drawing. So we are checking that particular feature with the help of, by that item is examined for non-conforming, whether it is conform or non-conforming, that we are checking with the help of examination. Next is decision. Now based on the examination, whatever we are doing, okay, a decision is made whether the item is satisfy the defined quality standard, whether that particular, as I have explained one feature, that is surface roughness, then surface roughness is okay or not, or whether it satisfy the defined quality standard. That is a quality, okay, I want 6.3 micron meter, okay, that is the surface roughness value, or 12.5 micron meter is the surface roughness value, or 25 micron meter is the as cast surface value. Okay, whether it is conforming, whether it is satisfying that defined quality standard or not. If it is not, then we are non-conforming that. Okay, if it is within that particular, it satisfies the defined quality standard, then we are accepting that particular component. That is, we are accepting that particular component, okay, and we are sending it to the inspection. Okay, next level inspection, that is whether we are just sorting and we are just keeping that particular parts in the safely in the SRS. Okay, now action, what is the last one in the procedure? That is action. What action we are going to take? So the decision should result in some action. So whatever decisions we are making, okay, whether it is conforming or non-conforming, whether it is accepted or not accepted, okay, so we are taking the decision, okay, the result in some action, such as accepting or rejecting the item, or sorting the item into most appropriate quality grade. So we are sorting those particular parts. Okay, though the part is within that particular limit, 100 parts within the limit, but the variation will be there. Though the tolerance band is given, but the variation, the parts are varied in that particular band. We are sorting those particular parts. Okay, say like say 0 to 50 micron is the tolerance given. So some parts are there within the 0 to 10, and 10 to 20, 20 to 30, 30 to 40, and 40 to 50. So we are sorting those particular parts and we are keeping for the assembly. So that, so whatever the male and female part is there, so accordingly whatever the fitment is given, like say whether it is a clearance fit, whether it is a transition fit, whether it is the press fit, okay, or interference fit. So accordingly we are just sorting those particular items, and then we are taking those particular items and we will fit those particular items in the assembly. So that is the action what we are taking. Okay, so here in this particular procedure, okay, you will learn about the presentation, how you are going to present the item, how you are going to examine the item, how you are going to take the decision, okay, whether it is satisfied or not, and then what is the action you are going to take, okay, for the most appropriate actions. Now inspection of accuracy, okay. So inspection accuracy, next part, okay. So this is the next part in the fundamentals of inspection. So that is the inspection of accuracy. This inspection of accuracy, third point, okay, inspection of accuracy. Okay, so inspection of accuracy. Now in this, okay, errors sometimes occurs in the inspection procedure during the examination and decision steps. So some errors, okay, will occur. See, the band is given, tolerance band is given for the fitment, for the assembly of the part, okay. Sometimes the errors will occur in the inspection procedure, okay. So whether it is the variables or something, okay, like say in the procedure also, okay, during the examination, that is how, whether in the procedure you might have seen the presentation, maybe in the presentation while presenting that particular item, okay, or keeping that item on the table and all those particular things, examination. So how you are going to examination the surface roughness, okay, how you are going to examine that, okay. So for the non-conforming of that particular feature, okay. Decision, while taking the decision whether it satisfies the defined quality standard or not. So defined quality standards, then actions, okay. So what action you are going to take, whether it is accepted or not. So these are some here in these out of these particular, for any in the procedure, any error will come sometimes in the inspection, okay, during the examination and decision steps, okay. Items of good quality are incorrectly classified as not conforming to specifications. So here items are, note, just check, items of good quality are incorrectly classified. Good quality, it is not classified correctly. The good products are there, the inspection is done, the decision has taken, action has taken, okay, everything is correct if it is satisfied, but still the quality or that particular this thing, the items of good quality are incorrectly classified. We are not classifying correctly as not conforming, okay, to specifications, okay. If it is not as per the specifications, and non-conforming items are mistakenly classified as conforming. So if the component is out of range, okay, out of tolerance band, okay, so those particular parts, okay, we are mistakenly classified as conforming, and some parts are within the tolerance band, okay, within the limit, but we are classifying them into non-conforming. So these are some errors, okay. So while sorting those particular parts, we are doing some mistake. Those particular errors will sometimes occur, okay, in the inspection procedure. So these two types of mistakes are called, what we are calling it as a type 1 and type 2 errors, okay. So these two, that is non-conforming and conforming type. So first, what is a type 1 error, okay. A type 1 error occurs when the item of good quality is incorrectly classified as being defective. It is false alarm. So here, type 1 error, how we are going to classify type 1 error. So good quality items incorrectly classified. Good, see, means as I have told, in the tolerance band, okay. So if the component, the diameter is given, say 100 mm, okay, plus or minus, okay, say plus side it is 0, okay, minus side it is 20 micron or 25 micron or 30 microns. But in case, in the case of the class type 1 error, okay, the good quality are incorrectly classified, okay. Now we know that the tolerance band is 0, okay, that is the lower side, and upper side it is upper side it is 0 and lower side it is 30 micron undersize, okay, of the shaft, but we are classified them into the incorrectly classified into defective part. So that is a false alarm actually, okay. Now type 2 error is when an item is poor quality is erroneously classified as being good, okay. If the type 2 error, the item of poor quality is erroneously classified. So see, if the band goes, if the band specified is plus 0 and minus 30 micron, okay, for the shaft, okay, and the poor quality means if the lower tolerances goes below, like say 20, more than 30 microns, okay, it is not acceptable, it is a non-conforming, but still we are classified as it is being a good product. So that is, it is a miss actually, okay. So this is about the type 1 and type 2 error. So next is, what are the type 1 and type 2 errors in the table? If you see the table here, okay, for the type 1 and the type 2 errors, the decision, confirming item and non-confirming item. So accept item, and whether we have to accept the item, decision is accept the item or reject the item. In the confirming item, good decision. If you go for the good, if you make the good decision, then we are confirming that particular item, okay. If your confirming item is a type 1 error, then it is a false alarm. Type 1 error is, yes, what I have explained just now about the type 1 error. So here the type 1 error, when an item of good quality is incorrectly classified, okay, as being defective, that is the type 1 error. So now here non-confirming item, type 2 error, that is a miss, okay. So acceptable item, so here type 2 error, when an item of poor quality is erroneously classified as being good, so that is a miss, okay. So same thing is in the table form I have shown here. Then the reject, how the decision is reject the item, okay. So type 1 error is false alarm. False alarm is this, okay. So again incorrectly it is classified, type 1 error. And here good decision, reject the item. Non-confirming means what? Good decision. If you are rejecting item, then it is non-confirming. It should be non-confirming item, okay, then your decision is good. If the confirming means if you are accepting the item within the tolerance band, then your decision is good, okay. So while sorting or while checking the inspection, while inspecting that particular dimension, the diameter, the length and everything, or whatever the different features are given in the drawing, so those particular features, okay, like surface roughness, okay, like the dimensions, like your other this thing, okay, about the materials, anything, okay. The confirming item means what? If you are accepting item, then it is a good decision. If you are rejecting the item, then it is a non-confirming, then it is a good, means you are just non-confirming that while checking. Once you inspect that particular component, when you check the component, when you check the dimension of the component, if it is not in the tolerance band, then you are rejecting that particular component, means you are confirming that, non-confirming that item, okay. So that is your good decision, that decision is your good decision. If you are accepting that, if the band, whatever the diameter is there, as I have told, okay, 0 is the upper limit, lower limit is minus 30 micron for the shaft. If you are considering, if it is within that particular limit, then you are accepting that particular item. So that is what you are doing, that is the decision. The decision is, the action is, you are accepting that particular item. So your decision is good, okay. So that is, you are confirming that particular item. So this, with the help of this particular table, you will come to know about the decision, whether you are confirming the item, whether you are non-confirming the item. So in the decision, whether you are accepting item or whether you are rejecting the item, okay. If you are confirming that, then it is a type 1 error, okay. Here, though the part is rejected, but you are confirming that part is okay. So that is a type 1 error, okay. That is a false alarm. If you are accepting the non-confirming item, then it is a type 2 error, that is a miss, okay. With the help of this particular table, you will come to know about the type 1 and type 2 errors. So next, in a manual inspection, these errors results from factors, okay. Some factors are there, okay, in the manual inspection. So errors results from the factors such as, first point is the complexity and difficulty of the inspection task, okay. If the dimension, if the part is a prismatic part, you can't check the dimensions of the, see, I want some, I'll just give one example of the manifold, okay. So if the dimension, okay, the diameter, the drill diameter, some drill holes are there in that particular manifold, and if you want to go for the inspection, if you want to check the hole with respect to some, say, the, the positional tolerance is given, in that particular case, your complexity will be increases. Okay, the complexity increases and difficulty in inspection task. Okay, you can't measure that particular part correctly in the manual inspection. So in that particular case, you have to go for CMM, coordinate measuring machines. With the help of, again, you are making that particular planes and creating the planes with respect to that particular plane, your position of the hole. With the help of that, you are checking the dimension of the other holes in the with the help of positional tolerances. Okay, so that is in the manual inspection it is not possible. So these errors result from the factors. So when the manual inspection, these type 1 and type 2 errors will be increased because of the complexity of the part or complexity of that particular feature. Okay, that you are going to check, and difficulty of the inspection task. It is very difficult. Sometimes in the prismatic component, it is very difficult to measure the hole dimensions. Okay, from the other side, from the front side, yes, it is possible. If it is open side, then it is possible. But if any curve type of shape and inside hole, if you want to check backside hole diameter, it is not possible. So that is the inspection difficulty in the inspection task. Okay, and in some cases you can't use the instruments, you can't move the instruments there, okay, and to check the diameter of that particular part. So that is a difficulty in the inspection task. So in that particular case, what the human inspectors are doing, yes, they will confirming that particular items. Though if the diameter is taper, okay, we are accepting that the diameter is okay, okay, if it is a through hole, okay, but we can't check the dimension of that particular hole backside. Okay, but though it is a taper, if the front side, the diameter is showing say 10 mm diameter and backside it is showing say 9.8, okay, but the tolerance band is given, it is plus or minus 0.5, then it is non-confirming. But still, if the inspector is confirming that, then it is we have to reject that particular component. But if it is if he is accepting that particular component, then it is a type 2 error. Okay, that is a miss. Okay. Next is the inherent variations in the inspection procedures. Okay, variations in the inspection procedures. Okay, inherent variation, different the procedure. As I have told, the first one is the procedure. In the procedure, the decision So inherent variations in the presentation, okay, that particular part you are presenting, okay, how you are going to present that particular part. Okay, I'll just give an example for this, okay, in the presentation. Okay, if I want to check, okay, if I want to check, I want to inspect that particular part for the inside blowholes, okay, so casted part or a machined part. Okay, first piece inspection I'm doing, okay, for the casted part or the blowholes, okay, to check the defect in the casting. In that particular case, how you are going to present that particular part, how you are going to keep the part on the machine table, okay, how you are going to keep the part on the table for the inspection in the non-destructive testing or in the non-destructive testing. So we are using, say if it is a ultrasonic testing or your liquid penetrant testing, okay. So for that, how you are going to present that particular part on the table, okay. If I want to check, so the defect, okay, or the size of that particular blowhole inside the casting, whether it is acceptable or not, that is the decision, okay, decision making we have to do. But what is the dimension, how you are going to inspect that particular thing, okay, whether it is whether that particular part is okay or not, okay, how you are going to check, okay. So how you are going in that particular case, how you are going to inspect that particular, how you are going to present that particular part, how you are going to keep that, okay, whether you are keeping that particular part horizontally or you are keeping that particular part vertically, that is very important. So that is the presentation, okay, the item is presented for the examination. So for to check the type 1 for the inspection, okay. So difficulty what we are facing in the manual inspection, okay, inherent variations, okay, in the inspection procedures, okay. Then we are going for the presentation and then the decisions, okay, examination, how you are going to examine that. Once the part is kept perfectly, then how you are going to examine. If it is not perfectly, how you are going to examine that. Okay, so it will give the error if you are not keeping that particular part, if you are not presented that particular part, okay, perfectly, then it will give errors, okay. Then the decision making is very difficult, then whether it is satisfied the defined standard or not, quality standard or not, that decision is very very difficult, okay. And then the action, okay, what action you are going to take, whether you have to accept that part or reject that part, because you have kept that, you have not presented that particular part properly for the inspection, so that is why it is giving error. So that is the procedure, okay. So here in the procedure, okay, if you check in the manual inspection, okay, so inherent variations in the inspection procedure, how you are going to keep that particular part, okay. So that is very important, okay. And then judgment required by the human inspector, okay, that is also these in the manual inspection, okay, judgment, okay, required by the human operator, whether I have to accept, whether I have to reject that particular component, that judgment is required by the human operator, okay. Mental fatigue in the human inspector, okay. So mental fatigue, okay, see that's why the 8-hour shift is made, okay. If we inspect, okay, daily around say 100-150 components, so morning his human efficiency is different, afternoon human efficiency is different, and evening his efficiency will go down, okay, it is different, okay. So that mental fatigue also plays very important role in the inspection. So that is also one factor, okay. This is also one factor which will increase the error of the component, okay. Inaccuracies or problems with the gauges or measuring instrument, okay, this is very important. Inaccuracies or problems with the gauges, okay, if the gauge is not calibrated, okay, usually the gauges, instruments, all the inspection instruments, okay. So those things we have to calibrate. If it is not calibrated, then the inaccuracies or problems with the gauges will come, okay, and then it will cumulatively the error is added, okay, and the component, though the component is accepted, okay, but we are rejecting that component, that is a type 1 error, okay. So that is inaccuracies or problems with the gauges or measuring instruments. So always we have to calibrate the instruments or gauges frequently, like say 6 months in a year, okay, once in a year or twice in a year, okay. So we have to it depends on again the accuracy of that particular the gauge, okay, whether we have to go for 6 months, in a 6 months we have to go for the inspection, okay, half yearly or yearly, okay. So that depends on this. So to reduce those particular error, type 1 error and type 2 errors, okay, in the manual inspection. When the procedure is accomplished by an automated system, inspection errors occur due to factors such as, so just now we have seen about the manual inspection. Now we are seeing here the procedure is accomplished by an automated system, okay. So inspection error occur due to the factors. These are the 4 factors, okay. One is the complexity and difficulty of the inspection task, similar type, similar, because if the probe is, if you are going for the automated inspection, okay, like say your CMM to 3D measuring instrument or a 2D measuring instrument, but the difficulty is the probe will not enter into that particular area, okay. It is very difficult. So that is the complexity of the part, okay, and difficulty of the inspection task. The probe is not entering, or you are not keeping, you can't keep those particular parts because a heavy part you can't keep on the table of the CMM. So these are the complexity of the parts, okay. Resolution of the inspection sensor. So like if you are considering the CMM, coordinate measuring machine, okay, what is the resolution of that particular sensor? Like say ruby rod is there, so one probe is there. What is the accuracy of that particular, or what is the resolution of that particular sensor, okay, which is affected by gain and similar control parameter settings. So you have to set the parameters accordingly. So, but though you are setting the parameters, but it is giving the if it is giving the false reading because of the resolution problem, okay. Third one is the equipment malfunction. If whatever the equipment is there, okay, if it is malfunctioning, then also the error increases, okay. So that equipment, say like your in the CMM only, okay, if you are taking that particular the ruby rod, okay, the probe, okay, where you are going to attach that particular probe, if it is malfunctioning, then it will give the error, okay. Next, fourth one is the faults or bugs in the computer program controlling the inspection procedure. If something, if we are writing the programs, okay, CMM program by using the joystick, by giving this particular touch sensors, okay, touch probe sensors we are using, and we are touching the surface. If you want to create the plane, and with respect to that particular plane, if you are taking that as a datum, and with respect to the datum you are checking all the different parameters in the casted part or a machined part, okay, holes, the thickness of the diamond, the thickness, the other the parameters, okay. So those particular faults or bugs in the computer, if some bugs are there in the computer, if it is not programmed properly, okay, the faults are there, then that will lead to the error, okay, in the inspection procedure, okay. So here this particular table, I want to explain about this particular table possible outcomes in the inspection procedure given Q, P1 and P2, okay. This is the true state of the items, okay. If the true state is like this, then the decision accept the item, reject the item, and what are the total items are there, okay. Whether it is confirming, the first column is a confirming, second column is pertaining to the non-confirming, and third column pertaining to the total items, okay, that the true state of the items, how many items are there. So here accept the item, okay. So P1 into bracket 1 minus Q, okay. So that is confirming, okay. If it is non-confirming, then it is 1 minus P2 into Q. That is the type 2 error, okay. Type 2 error already I have explained. Total is P1 plus Q, P1 plus Q into bracket 1 minus P1 minus P2. That is the total item to be in the true state, okay. Then the items, those are the total number of items, okay, confirming and non-confirming items. Rejecting the item 1 minus P1 into 1 minus Q, that is a type 1 error here, and P2 into Q. So total items are 1 minus P1 minus Q into bracket 1 minus P1 minus P2. So that is the total items, okay, in the true state. So the total, okay, confirming is how much? 1 minus Q, okay, by just the calculation, okay, this will come under 1 minus Q, and the non-confirming is Q, and that total items, okay, if you are checked, then it is 1.0, okay. So this is the procedure, okay, given for the confirming and non-confirming of that particular items, okay, Q, P1 and P2. So the next one is inspection versus testing. So now here in this particular inspection, so this is the third part, okay, in the inspection and the last part, sorry, in the fundamentals of inspection. This is the inspection versus testing. Okay, so this is till now we have seen what are the types of inspection, inspection procedure we have seen, inspection accuracy we have seen, and now inspection versus testing. Okay, so inspection versus testing. Okay, so here quality control utilizes both inspection and testing procedures to detect whether a part or a product is within design specification. Whatever design we are making, okay, as a design, the design engineer will make that particular designs. The draftsman will use his skill and he will draft that particular parts, individual parts for the shop floor machining. Okay, so quality control, okay, utilizes both. Okay, that is inspection and testing procedures. The inspection procedures, testing procedures. So how you are going to test that particular part. Okay, whether it is okay or not, whether it is confirming or non-confirming. Detect whether the product is within the design specification or not. Okay. So design specification means what? Testing, okay, whether the leak testing, okay, after assembly we are doing the leak testing, okay, for the, see, you take any the walls, okay, if I am taking the example of walls, okay, after doing assembly, okay, we are going for the testing operation. That is the final inspection, testing. So that inspection is testing. What in that particular testing, what we are doing? So earlier in the inspection, okay, we are doing all the dimensional features. We are checking the dimensional features, okay, like say diameter, your length of that, and the thickness of the casting defects, other thing, initially casting defect. Then next, okay, you are checking, you are doing the machining operation. That is the process, okay, process features like say surface roughness you are checking. After machining, you are checking the dimensions, surface roughness features, other features, okay, and then after that you are going for the assembling of that particular part. Once you assemble all the parts, then you are checking for the testing. Then comes your leak testing, okay, then comes your whether the part is fit according to the standard or not, quality standard, that is your fitment, okay, whether it is an interference fit, whether it is a transition fit, whether the fitment is the clearance fit. So that we are testing in the testing procedure, okay. So as per design specification, whatever the design is specified, whether it is there accordingly or not, okay. So that we are checking. Next, inspection is used to assess the quality of the product relative to design specification. So quality of the product, whether it is the sound quality or not. So that relative to the design specification we are checking. Okay, used to assess the quality of the product. Third one is testing is a term in quality control that refers to assessment of the frictional aspect of the product. So the functional aspect of the product. So this will assess, okay, the functional aspect of the product. Testing is a term quality control that refers, okay. So in this is also quality. So we are checking the leak testing, okay, that is also quality. It should not leak, okay. So in the pump, okay, pump should not leak. So some standards are there, quality standards are there for the pumps. So testing in terms of the quality standard we are doing, okay, refers to the assessment of the functional aspect of the product, the functionality of that particular product, okay. So because we are applying more pressure, the water or oil, okay, which is flow through that particular pump, okay, so it should not blast, okay. When you are operating that particular valve, close and opening of the valve, okay, at that particular thing we have to see, okay, what is the, see the dimensional specification is the thickness of that particular valve. Wall thickness should be this much. So that they will give in the design specification. So you have to manufacture that particular part according to the design. That is the relative to the design specifications, okay. You have to manufacture according to that, and then what they will do, this is the one example what I am giving. What they will do, they will go for the non-destructive testing. They will check the thickness of the valve, okay, within the range or not. In the range is given. If it is not in the range, then they will non-confirming that. If it is in the range, then they will confirm that particular valve body, okay. Then the quality control that refers to the assessment of the functional aspect of the product. That the functionality is, yes, the water is flowing, okay, with the high pressure, or the oil is flowing through that particular pump with the help of high pressure. When you close that particular wall, okay, at that time that particular pressure will induced on the wall, okay, so that should sustain that particular pressure. So that is we are doing in the testing, okay, of with the help of some test rigs we are checking that particular the failure of that particular part, okay, or for how many cycles, okay, it will fail. So that decision we will take, okay, with the help of testing. Example, now here one example is stress load equal or greater than the load anticipated during the normal service. If I am applying the load, okay, whether it is equal or it is more, okay, then that we are anticipating during the normal service. So whenever we are doing the normal service, okay, how much stress is coming on that, okay. If you take one example of the screw jack, okay, so whenever the vehicle, okay, tire gets punctured, okay, at that time, okay, we are using the screw jack. So whatever the load is coming, whether it is according to that, whatever the design specification is there, so whether it is meeting that particular design specification or not, okay, design specification or not, so how much stress is inducing on that particular the cup part, okay, so that is whether it is equal or it is a greater. If it is a greater, then that part will fail, okay. So how much in the normal service, how much load we are taking. So in the design specification only we are taking design the factor of safety 4 times or 3 times factor of safety in the design specification, and to manufacture that particular part for checking the stress, okay, coming on that particular part, or we are going for the analysis. Initially we are doing the analysis of that particular part for this particular stress loads, okay. And then the non-destructive testing and non-destructive evaluation, okay. So the same thing I have explained about, I have given one example of the wall, okay. So we are doing the non-destructive testing to check the thickness of the wall, okay, once it is manufactured. If it is not correct, then again we are just modifying the patterns, and then we are going for this again manufacturing of that part. Then again we are just slicing that particular part, and we are doing the non-destructive testing, and then we are checking the thickness of the wall, because the functional specification is aspect in the part is the thickness of the wall. We should not break, should not